This video is going to show you how to solve an example problem with circular motion. Near Charlottesville's airport, there's a piece of roadway called a roundabout. The main feature of this piece of roadway is a circle vehicles travel on. A car travels around the road in a diameter of 30 meters at 7 meters per second. How much time does it take to travel halfway around the circle? So you can see on this Google Maps image that I have down here, this is the actual roundabout I was speaking of. And you can see there's actually a car on it right there in the center. To help identify this a little bit, let me highlight it. So now you can see that that's the circle that we're talking about the car traveling on, and that's got a diameter of 30 meters. So let me get rid of some of this, shrink it down. Here's the strategy. First off, it's circular motion. Because it's circular motion, that means I've got all these equations that I can work with, including F equals ma, which isn't listed there, but this problem ended in about 4, so I'm not listing it. And the question says to find the time to go halfway around a circle. Well, in my equations, I don't have anything for time like that, but I do have t, capital T, meaning the period, which is the time to go all the way around once. And since this is the time to go around halfway, if I find t, I can just divide it by 2, and that'll give me the answer to the question. And finally, the other thing that's up here, or not finally, but the other thing that's up here is that, remember that half the diameter is equal to the radius. So they've given me the diameter in the problem, and I can find the radius. That's going to help me since all my formulas deal with the radius. So now what I'm going to do is I'm going to look for unit clues to help me determine the variables. So here are the givens. I've got 30 meters. That's a distance formula talking about circular motion. In this case, that's talking about the diameter, which therefore I know because the radius is half of that, the radius is equal to 15 meters. The 7 meters per second, well, that 7 meters per second, those units of meters per second kind of give it away, that that's going to be the velocity. Actually, it's the tangential velocity of it going around. And I'm looking for the period. So now, process of elimination, find the formula that has my variables of r, v, and t in it. So if I look at the first one, v's in my list of givens, t's in my list of givens, ac is not in my list, so I'm not going to use that. The next formula, r's in my list, t's in my list. Again, ac is not in my list, so I'm not going to use that formula. Next equation, v is in my list of givens, r is in my list of givens, ac, again, not in my list of givens. So that's 3 formulas I've knocked out that I'm not being able to use. Final formula, the r's in my list of givens, t's in my list of givens, and the tangential velocities in my list of givens. So there we go. That's going to be the formula that I want to use to solve this problem. Okay, tidy up the screen a little bit. So I'll start with vt is equal to 2 pi r over t, put in my numbers with units, always numbers with units. Then I'll suppress the units because I'm working within this system. And when I do that, I'll isolate t, which means multiplying both sides by t and dividing both sides by 7. That's how I get this expression. And that gives me the time to go around once. But the question was, how much time does it take to go halfway around? So I'll divide this by 2, and that'll give me the final answer to the question. Notice that when I'm talking about the period, it's a capital T for the variable, and when I'm just talking about a general time, as in time for the answer, I'm using a lowercase t for the answer. So 6.73 seconds is the time to go around once.